Hello dear students, in today's class let us discuss balancing of redox reactions. So redox reactions are those reactions in which oxidation and reduction occurs simultaneously. Okay, so in order to balance a redox reaction you have two methods. So first method what you have is oxidation number method, and the second method what you have is half reaction method. So there are two methods of balancing of redox reactions. Okay, so let us consider oxidation number method. Okay, so there are certain steps in order to find out the oxidation number method for balancing the redox reactions. So how do you do, or how do you balance the redox reaction using oxidation number method? Now for example, you have a reaction of this kind. So Cr2O72 minus aqueous medium plus SO3 minus, this is also in aqueous medium, giving rise to Cr3 plus aqueous plus SO4 minus aqueous, and the reaction is occurring in acidic medium. Okay, so they have given us to balance this reaction using oxidation number method. So first step is, whatever the reaction is given to you, you are supposed to write it as it is. Copy down the reaction first. Okay, so first step is you will be writing the reaction as it is. Okay, in the second step you are supposed to write the oxidation states of each and every element. Okay, in the second step you will be writing oxidation states of each and every element. Now here you can see, now we know how to find out the oxidation state of each element that we have discussed. Okay, so here chromium is in +6 oxidation state, oxygen is in -2 oxidation state, sulfur +4, oxygen -2, chromium 3+ is there, so this will be the oxidation state 3+. Here sulfur is in +6 and oxygen -2. Okay, now after you write the oxidation states of each and every element, next thing is you are supposed to find out which is undergoing oxidation, which is undergoing reduction. Okay, now here if you see, chromium is in +6 oxidation state, it is changing to +3 oxidation state. So how do you define oxidation and reduction in terms of oxidation number? So increase in oxidation number is oxidation, decrease in oxidation number is reduction. So here what is happening is +6 oxidation state is changing to +3 oxidation state. So there is a decrease in oxidation number. So decrease in oxidation number in the sense chromium is undergoing reduction. Okay, now oxygen is in -2 oxidation state, there, so no change, we are not considering this. So sulfur, if you take, sulfur is in +4 oxidation state, it is changing to +6 oxidation state. So what is happening here? From +4 it is changing to +6. So there is an increase in oxidation number. So sulfur is getting, it is getting oxidized. So chromium is getting reduced because it is changing from +6 oxidation state to +3 oxidation state, whereas sulfur is getting oxidized. Why? Because it is changing from +4 to +6 oxidation state. Okay, so first you are writing the equation as it is, then you are writing the oxidation states of each and every element, and then you are finding out which is undergoing oxidation and which is undergoing reduction. Then you are finding out by how much increase there is oxidation number or how much decrease is the oxidation number. So oxidation number increases by how much, oxidation number decreases by how much. Okay, so +6 to +3, so there is a decrease in oxidation number. So 6 is changing to 3, in the sense there is a decrease of +3. Okay, 3 oxidation number decreases by 3, but there are 2 chromium atoms, so this decrease 3 is multiplied by 2 per molecule. Okay, so you are supposed to multiply it by 2. Why? Because you have 2 chromium atoms here. Okay, so sulfur, if you consider +4, it is changing to +6. So you have only one sulfur here, here also one sulfur. So +4 to +6, how much increase it is? So oxidation number increases by 2 per atom. Okay, so here oxidation number decreases by 3, it is multiplied by 2 because we have 2 chromium atoms. So here we don't multiply it by anything because you have only one sulfur atoms here on either side. Okay, so this is your increase or decrease. So next step what you have is calculate the increase or decrease in oxidation number per atom. Okay, next is you equate those two equations. Okay, so this is as it is, Cr2O7 2-, I'll write it as it is. Now here, so it is changing, oxidation number is increasing by 2 per atom. Next what you are supposed to do is you are supposed to equate the increase and decrease in oxidation number. Now here how much the oxidation number is decreasing? 3 into 2 is 6. Now here it is how much? It is 2. So both these equations have to be equated to 6. So this equation you have to multiply it by 3. So this equation you are supposed to multiply it by 3. So what happens here? Cr2O7 2- plus this equation in the sense 3SO3 2- giving rise to Cr3 plus and 3SO4 2-. Okay, next what you are supposed to do is, next you are supposed to balance the equation with respect to all other atoms except hydrogen and oxygen. So balance all other atoms except hydrogen and oxygen. So how many chromiums are there? 2. So here write it as 2 chromiums. Okay, so 2 chromiums are there, so this also should be made 2. So I have written 2 Cr3 plus. So oxygen later we have to balance. Sulfur you check, there are 3 sulfur atoms, here also there are 3, so no need to change, so it is 3 sulfur. So only this is changing here, Cr2 plus and 2 Cr3 plus. Okay, so you are supposed to balance all other atoms except hydrogen and oxygen. Okay, next you are supposed to balance hydrogen and oxygen. So to balance hydrogen and oxygen, you are supposed, for balancing oxygen, you are supposed to add water molecule to the side deficient of oxygen. Okay, so balancing of hydrogen atom, if you want to do, that depends on what medium is the reaction. Okay, if the reaction is in acidic medium or basic medium. Okay, if the reaction is acidic medium, that many number of H plus ions has to be added to the deficient side. Okay, if the reaction is taking place in basic solution, then you are supposed to add water molecule to the deficient side and equal number of OH minus to the other side. Okay, so balancing of hydrogen and oxygen should be done at the end. Okay, so when you are starting with the balancing of hydrogen and oxygen, first you are supposed to balance oxygen atoms. To balance oxygen, what you should do, you should add that many number of water molecules to the deficient side. Now we'll check how many oxygens are there. Now here you have 7 oxygen atoms. Okay, plus here 3's are 9. 9 plus 7 is how much? 16. 16 oxygen on the left side. So here how many you have? 4 3's are 12. 12 oxygen on the right side. And here you have 12 oxygen, right? So 7 oxygens plus 3 3's are 9. 9 plus 7 is 16 oxygen on the left side. Right side what you have? 4 3's are 12. 12 oxygen. So 16 here and 12 here. So where the oxygen is deficient? To the product side. So how much it is deficient? Here it is 16, here it is 12. So 4 deficient oxygen. So I am adding 4 water molecule. So to balance oxygen, you are supposed to add that many number of water molecules to the deficient side. So right side it was deficient. So I have added 4 water molecules. Okay. Next, finally, you are supposed to balance the hydrogen. So to balance the hydrogen, you are supposed to check the medium. So here the medium is acidic medium, correct? So here acidic, here if you consider hydrogens, so here 4 2's are 8 hydrogens are there. Okay, so 4 2's are 8 hydrogens. So here on the deficient side you are adding hydrogen atoms. Okay, so this is in acidic medium, so I am not adding OH minus on the other side. Okay, so in acidic medium, when you are balancing the hydrogen atoms, you are just adding the deficient number of hydrogen atoms. So 4 2's are 8, 8 hydrogen atoms are there. So that many number of H plus ions I will be adding to the deficient side. If it was basic medium, these many H plus. On the reverse side, you are supposed to add OH minus. Okay, so this is what is the final balanced equation by oxidation number method. We'll take one more example to solve. Balance MnO4 minus plus Br minus giving rise to MnO2 plus BrO3 minus, and the medium is acidic here. Okay, so first you are writing the equation as it is, then you are writing the oxidation states of each element here. So manganese is in +7 oxidation state, Br is -1, here manganese +4, Br here is +5. Okay, so manganese is changing from +7 oxidation state to +4. In the sense manganese is undergoing reduction. Okay, so for +7 to +4, in the sense how many degrees it is, so change in oxidation number is 3. Okay, 7 to 4 is in the sense 3, change in oxidation number is 3. Okay, so Br minus is -1 oxidation state is changing to +5. Okay, from -1 it is changing to +5, in the sense how many change, -1 is there, 0, 1, 0, 1, 2, 3, 4 and 5. So oxidation number change will be 6 here. Okay, so here the change is 3 and here change is 6. So these two have to be equated. So this also has to be made 6. So you have to multiply this equation by 2. Okay, multiply this equation by 2. So what happens, it becomes 2 MnO4 minus. So that is what is written here, 2 MnO4 minus plus Br minus as it is. So this again multiply by 2, in the sense 2 MnO2 plus BrO3 minus. Now you have to balance all other elements except hydrogen and oxygen. Now here 2 Mn are there, here also there are 2 Mn, 1 Br is there, here also there is 1 Br. Okay, so no change, 2 Mn, 2 Mn, 1 Br and 1 Br. Next is to balance the oxygen atoms. So to balance the oxygen atoms, you are checking the medium in which it is carried out. Okay, so as because the medium is acidic medium, so here you have 4 2s are 8 oxygen atoms on the left side. On the right side what you have is 4 2 2s are 4, 4 plus 3, 7. Okay, so 7 on the right side, 8 on the left side. So here there is one oxygen deficient on the product side. So whenever you have the oxygen deficient, on whichever side it is, you are supposed to add that many number of water molecules. So one oxygen is deficient here, so one water molecule you will add to the product side. So I am adding 1 H2O. Okay, next you are supposed to balance the hydrogen atoms. So to balance the hydrogen atoms, when it is acidic medium, you are supposed to add H plus ions to the deficient side. Okay, now here how many hydrogens are there? There are 2 hydrogens. So 2 H plus ions are being added to the deficient side, that is the reactant side. So the final equation will be 2 MnO4 minus plus Br minus plus 2 H plus giving rise to 2 MnO2 plus BrO3 minus plus water. So this is the final balanced equation. Now let us look into the second method of balancing the reaction, that is half reaction method. So in this method you are supposed to write down the equation first, then find out which element is undergoing oxidation and which is undergoing reduction. Then here half reaction method, in the sense you are separating the oxidation and the reduction reaction separately, balancing them separately, and then you are combining them, both the equations, and then you are getting the final equation. So here we do the balancing by separating both the oxidation and the reduction reaction, balancing them and getting the final equation. Okay, so let us consider an example of this kind. MnO4 minus plus I minus giving rise to MnO2 and I2. Okay, so here what are the oxidation states of different elements here? So manganese is in +7 oxidation state. Okay, so here oxidation state of manganese is +4, iodide ion is -1, iodine as it is in free state, its oxidation state will be 0. Now here manganese is changing from +7 oxidation state to +4 oxidation state. There is a decrease in oxidation number. So this I can call it as a reduction. So manganese is undergoing reduction. iodide ion, which is in -1 oxidation state, is changing to 0. In the sense there is increase in oxidation number. In the sense it is undergoing oxidation. So iodide ion is undergoing oxidation. Manganese is undergoing reduction. So separate these two equations. So first is we'll balance iodide ion, then we'll balance manganese. Okay, so oxidation, as we all know, it is loss of electrons. Reduction is what? It is gain of electrons. So oxidation is loss of electrons. How many loss of electrons we are supposed to check? Okay, so here I minus is changing to I2. So here two iodide atoms are there. Here there is only one iodide ion. Okay, so you have to balance this. So 2I minus giving rise to I2. Okay, so 1I minus is changing to I2. Change in electron is 1. If I take 2 iodide ions, change in electron will be 2 electrons. So 2 electron is lost. Why? Because iodide ion is getting oxidized. Manganese, if you consider, okay, manganese, so MnO4 minus is giving rise to MnO2. So this is reduction reaction. Reduction means gain of electrons. So how many electron change it is? Mn plus 7 to plus 4. So what's the change? 3 electron change. So reduction means gain of electrons. So that gain of electrons I should add to the reactant side. So how many electrons should I add? 3 electrons. So MnO4 minus plus 3 electrons will give you MnO2. Okay, now you balance all other elements except hydrogen and oxygen. So here Mn, 1 Mn is there. On the product side also there is 1 Mn. So this is balanced now. Next, what you are supposed to do? You are supposed to balance oxygen atoms. Okay, so to balance oxygen atom, check the medium. So what is the medium here? The medium is basic medium. So when the medium is basic, you are supposed to add OH minus to balance the oxygen atoms. Okay, so how many oxygen are here? There are 4 oxygen atoms. On the product side, how many oxygens you have? You have 2 oxygen atoms. So where there is deficient of oxygen? To the product side. By how much it is deficient? By 2. Here it is 4, here it is 2. In the sense, in the product side you have 2 oxygen atoms deficient. So to balance oxygen in a basic medium, I have to add OH minus. So I'll add 2 OH minus on the product side. Okay. Now you have to balance hydrogen. To balance the hydrogen atoms, you are supposed to add water to the deficient side and equal number of OH to the other side. Okay, so how many hydrogens are there here? 2 hydrogens on the product side. So I have to add water on the opposite side, here 2 water and 2 OH minus on the other side. So that only has been done here. MnO4 minus plus 3 electrons. So this 2 water I am adding because you have 2 hydrogen atoms. So due to these 2 hydrogen atoms, to balance hydrogen, we should add water on the deficient side. So the reactant side we are deficient with hydrogen. So I am adding water here. Okay, and equal number of OH minus is to be added on the other side. Other side means here the product side. So MnO2 plus 2 OH minus, this was already there. So in addition to that, due to addition of 2 water, I should add 2 OH minus. Okay, to the other side. Okay, so this is the reaction. So manganese is balanced now. Iodine is also balanced, manganese is also balanced separately. So first you are separating the oxidation and reduction reaction, balancing them separately. Then you are supposed to add the 2 half reactions. So now I'll add the 2 half reactions. So which was the first half reaction? This thing. So second half reaction, I'll write it as it is. Now, how many electrons are here? There are 2 electrons. How many electrons you have here? There are 3 electrons. So here 3 electrons, here 2 electrons. So balance these 2 electrons here. So multiply this equation by 3 so that it will be 6 electrons. Multiply this equation by 2 so that again it will be 6 electrons. So this 6 electrons and this 6 electrons will get cancelled. So what is left now? 2 MnO4 minus plus 2 2s are 4, 4 H2O plus 3 2s are 6, 6I minus giving rise to 3 iodine, 3I2 plus 2 MnO2 plus 4 2s are 8, 8 OH minus. So this is the final balanced equation. Let us consider one more example. Let us consider one more example here. Fe2 plus Cr2O7 2 minus, giving rise to Fe3 plus and Cr3 plus aqueous. So the medium here is acidic medium. Okay, so Fe2 plus is changing to Fe3 plus. So it is undergoing oxidation. So oxidation reaction, I'll write it separately. Fe2 plus to Fe3 plus. So how many electron change it is? It is 1 electron. So oxidation is loss of electrons. So I will write that 1 electron towards the product side. Okay. So Fe2 plus giving rise to Fe3 plus this 1 electron. Okay. Which is chromium plus 6 is changing to chromium plus 3. So it is undergoing reduction. So reduction reaction I'll write separately here. So plus 6 is changing to plus 3. So there is a change in 3 electrons. So as because you have 2 chromium atoms, the change in electron will be 6. Reduction is gain of electrons. So write these 6 electrons towards reactant side. So Cr2O7 2 minus plus 6 electrons giving rise to 2 Cr3 plus. So we have balanced this chromium also, 2 Cr3 plus. Okay. Now you are supposed to balance oxygen atoms here. So how many oxygens are there here? 7 oxygen. So to balance oxygen, medium is acidic, so you have to add water. So 7 water molecules is added to the deficient side, that is the product side. Okay. Next is to balance the hydrogen. So how many hydrogens are there? 7 2s are 14. 14 hydrogens are there. So to balance that, I have to add that many number of H plus to the deficient side. So I'll be adding 14 H plus on the deficient side. So I'll get Cr2O7 2 minus plus 6 electrons plus 14 H plus giving rise to 2 Cr3 plus 7 H2O. So these two reactions, oxidation and reduction reactions, are balanced. Next thing is you are supposed to add these two reactions. Okay. So take the oxidation reaction, take the reduction reaction. So how many electrons here? There is only 1 electron. How many electrons are here? 6 electrons. So make these electrons same. So for that you multiply this equation by 6. So that here also there are 6 electrons and here also 6 electrons. Both these electrons will get cancelled. Okay. So what is left out? 6 Fe2 plus Cr2O7 2 minus plus 14 H plus giving rise to 6 Fe3 plus 2 Cr3 plus and 7 H2O.